So this is a video that goes over the coordinate proofs that we worked in class that went with 4.7 notes. This was day 2 whenever we were using the distance and midpoint formula, but we were using variables instead of number coordinates. So if you were not sure on some of these or you needed some more explanation and couldn't come into tutoring, this would be the video for you. So look at number 1. What they've done here is they've given us that angle B is a right angle in triangle ABC. So they gave me a picture here, but had they not given you a picture, you would have known to situate your triangle where angle B was at the origin, because that's your right angle, and then your other two vertices would be labeled A and C. Then they also told you that D is the midpoint of AC, which they have placed right here, and you notice that they have put the little congruent marks there for you. And then you're trying to prove that the area of triangle DBC is half the area of triangle ABC. So on this first proof, they've given you some support. They gave you the picture. They told you in blue here how they labeled their coordinates, how they chose to do 0, 2j, and 2n, 0. Since you're using midpoint, you want to use multiples of 2 for your leg lengths. Okay, so they've done that for you in step 1. Step 2, positioning the figure in the coordinate plane is done here, and now we're going to actually write our coordinate proof. So the first thing that we need to do here is we need to go ahead and find the coordinates of point D, which we can do by using the midpoint formula. So you could say, using the midpoint formula, we can find the coordinates of D. So remember the midpoint formula, all you're going to do is you're going to stack your coordinates. So we have 0, 2j, and we have 2n, 0. You stack them and add them. So we have 2n, 2j divided by 2. So when I do that, I'm going to find out that the coordinates of D are going to be n, j. And you can see my work there. Then once I have the coordinates of D, I know that I can find the height of this triangle by looking at the y-coordinate of D, right? So this is going to be the height of triangle DBC. Okay? But I need to find the base. So I need to go ahead and use the distance formula. So I'm going to use the distance formula to find BC. And so when I do that, remember you're going to subtract your x coordinates. So you have 2n minus 0 squared, and you're going to add that to the difference of your y coordinates squared. So that would be 0, 0 squared. Well, 2n minus 0 is 2n, so we're finding the square root of 2n squared. And then 0 minus 0 is 0, and when you square that, you get 0. So I'm just dropping that off. To undo a square, you take the square root. So the square root of the quantity 2n squared would just be 2n. Okay, so now I know the base of that triangle, or the length, or the distance between B and C is 2n. That will allow me to find the area of the triangle. So the area of triangle DBC can then be calculated using base times height divided by 2. So my base was 2n, my height was j, and I'm going to divide that by 2. And I know that those are going to divide out, and that means the area would be nj. Okay, so now that I have the base, I have the length of BC, I can use the distance formula to find the distance between A and B. So I'm going to be using that distance formula again, but I'm going to use it to find the distance between A and B. So here, I'm going to do the difference of my x values, which in this case it was 0 minus 0 squared. I'm going to add that to the difference of my y values, which is 2j minus 0 squared. And you should notice this is similar because I wind up with having 2j squared under my square root, so I know that that's going to be equal to 2j. So now I can find the area of triangle ABC, because remember we're trying to compare those two. So I'm going to do that using base times height divided by 2 once again. So I know that my base of my triangle was the distance between B and C, which I calculated as 2n. I know that the height of my triangle would be the distance between A and B, which I calculated as 2j. And then I'm supposed to divide that by 2 to find area. So 2 times 2 is 4, nj over 2. I can divide here, and I find out that the area of that triangle would be 2nj. So that was a lot of work, I realize that, but if you organized yourself, you know that you are looking at the area of these two triangles, because right here in the proof, it's saying, is the area of triangle DBC 1/2 the area of triangle ABC? And yes, it is. And you can see that 2nj and nj, the relationship there is that this one would have half the area. Okay, so you would just have to make that statement. Okay, let's go ahead and move on to number 2. Okay, so what I noticed whenever I was talking to you guys about this in tutorials and in class is that what was throwing you off is how to actually place your figure in the coordinate plane and label the coordinates. So I'm going to kind of walk you through this even though I've started drawing my diagram. So if you look at the given, it says that angle R is a right angle in triangle PQR. So that gave me a lot of information to start with. So since R was the right angle, I went ahead and placed that at the origin because that is going to be the easiest place for me to put a triangle that has a right angle. Okay, because that was one of the things we talked about when we talked on Wednesday, when we started 4.7, one of those strategies. So then what I'm going to do is I'm going to look, and I notice that I know the triangle is PQR, so if this is R, then these points have to be P and Q. So I chose to use P down here on the x-axis, and it tells me A was the midpoint of PR. So I know that point A would be halfway between R and P. And obviously I'm eyeballing this. I'm going to use my coordinates to prove it. Then it tells me that B is the midpoint of QR, so I have QR here with B at the midpoint. And you could make your little notations, you know, to let yourself know that those are indeed the midpoint, but we're going to use our midpoint formula to actually prove it. Okay, so from here what you want to do is you want to go ahead and, just like on the last one, I would encourage you to use multiples of 2 or something that's going to be divisible by 2 since you're using midpoint. So the coordinates of P, I'm just going to use as 2a, comma 0, because I don't really know the coordinates of A, but I know 2 times that will give me the coordinate of P since it's a midpoint. Now I'm going to have to prove that in a moment, but that's how I get my coordinate. Then the same thing for Q. So I know that 0, comma 2 times whatever the coordinates of B are will be a good coordinate for Q. Okay, so now I'm actually going to start using the distance in the midpoint formula. So I want to use midpoint. So using midpoint, I'm going to go ahead and find the coordinates of B and A. So to find the coordinates of point B, I am going to stack Q and R's coordinates. So I'm doing 0, comma 0, and 0, comma 2B. And I'm adding those together and dividing by 2 to find the midpoint. And when I do that, I find out that the coordinates of B should be 0, comma B. Then to find the coordinates of A, I'm going to do the same thing. So I'm going to stack R and P's coordinates. So I have 0, 0, and I have 2a, comma 0. I'm going to add those together. I get 2a, comma 0, and I'm going to divide by 2, and the coordinates of a should be a, comma 0. Okay, so now that I know those coordinates, what I'm trying to prove is that AB, so I'm trying to prove that this distance is half the distance of PQ. Okay, so I need to use the distance formula. So using the distance formula, I am going to calculate, I want to find the distance between A and B. Okay, so I'm going to subtract my x's, so I have the difference of your x's squared, so I have 0 minus a squared, and I'm going to add that to the difference of my y's squared, so b minus 0 squared. So 0 minus a would be negative a squared, but when you square negative a, you're going to just get a squared. And b minus 0 is b squared would be b squared. Okay? So I know that the distance between a and b is the square root of a squared plus b squared. Now some of you yesterday, you kept trying to actually square root these. So remember, because this is addition, I can't take the square root. I can't break this binomial up and take the square root of its individual terms. Okay? All right, so now I know the distance between a and b, and it is the square root of a squared plus b squared. Now I'm going to find, using the distance formula again, I'm going to go ahead and find the distance between Q and P. So I want to find that. So I have the difference of my x's, so I have 0 minus 2a squared plus the difference of my y's squared, so 2b minus 0 squared. Now this one's slightly different because we have coefficients. So when I do negative 2a squared, I'm actually going to wind up with 4a squared. Don't forget that that coefficient gets squared too. And then 2b minus 0 is 2b, and when I square that, I'm going to get 4b squared. Now this one's a little bit different than the last one because I actually could factor. So you notice that there is a GCF here. That 4 can be factored to the front, and I'll be left with a squared plus b squared inside parentheses. Now the reason that I would factor that is because 4 is a perfect square. So if I take the square root of 4, I get 2, and then my non-perfect square, my a squared plus b squared, stays underneath. Now you may be wondering, well, why would I need to do that? Well, I'm trying to prove that this is half of this. And you can clearly see that if this one is twice that one, then it would be half. So I have now proven that AB is equal to half of PQ because the square root of a squared plus b squared is half of 2 square roots of a squared b squared. So I'm using this right here because this is half of that. Okay? All right. Let's go ahead and look at number 3. Okay, so I've already drawn my diagram again, but I'm going to go ahead and walk you through how I got these coordinates and whatnot. So what they've given me here is that E is the midpoint of AB and rectangle ABCD. So I chose to orient my rectangle where A, B, C, D is like that. And then I placed E at the midpoint between A and B. And then F was our midpoint of C and D, so I placed F here between C and D. I made my notations on my grid. Then to get my coordinates, I chose to use B at the origin, and since I know I'm going to be using midpoint once again, I have this coordinate as 2A, comma 0, and this one I used as 2C, comma 0, and so that would make the coordinates of D. I would have to go over 2C and up 2A. Oh, I just noticed that I labeled that incorrectly here. Let's go ahead and fix this one. So this would be 0, 2a. Let's try that. So I know that I would go over 2c and up 2a, and that gives me those points. Okay, so I am trying to prove that EF is congruent to AD. Okay, so the first thing that I need to do is calculate the coordinates of E and F. So I'm going to go ahead and I'm going to use my midpoint formula to do that. And I am going to find the coordinates of E by stacking 0, 2a, and 0, 0. So 0, 2a, and 0, 0. You add those together, you get 0, 2a, you divide by 2, and you find out that those coordinates would be 0, a. To find the coordinates of F, I'm going to stack D and C's coordinates. So I have 2c, 2a plus 2c, 0. And when I do that, I'm going to get 4c, 2a. And then when I divide by 2, 4c divided by 2 would be 2c. And 2a divided by 2 is just going to be a. Okay, so now I have my coordinates of E and F. I needed those coordinates because I need to find the distance. So I'm going to now use the distance formula because I want to find the distance between points E and F. So I'm looking for the distance between those. So the difference of your x's squared would be 2c minus 0 squared plus the difference of your y's, so a minus a squared. 2c minus 0 squared is going to be 2c squared, and a minus a is 0, and 0 squared is 0. So I know that the square root of 2c squared would have to be 2c, which is how long EF would be, right? Okay. Now what I need to do is I need to find the distance between A and D. So I'm still using my distance formula, but this time I'm looking at AC. So the difference of your x's would be 2c minus 0, and you're squaring that. So notice it starts out similar, plus the difference of your y's, which happen to be 2a and 2a. So anything minus itself is 0, squared is 0. And then notice that we have our 2c squared left under our root symbol, which means that AC is also equivalent to 2c. So I'm looking at this portion right here, and I can now say that EF is equal to AD. All right, that one seemed a little bit easier than the last couple that we've worked, a little bit less work, but as you notice, we're using the same mathematics. We're using our midpoint formula to find the coordinates, and then we're using distance formula so that we can actually prove something about those lengths. Okay, go ahead and let's look at number 4.